Starting FHS today is Wednesday, March 27th, 2024. Would you please join me in a minute of silence? Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
Good morning, guys. So today we are moving on to the second section, 3.4. And unlike 3.3, we'll spend kind of like a class and a half on this one. This is definitely the most important section that we do with logarithms. In fact, pretty much the only reason that you learn logarithms in Algebra 2 and get tested on it on ACT and all of that kind of stuff is for what we are trying to use them for today, which is in solving equations. So these can build up to be pretty tough questions occasionally, but in our notes here, I do kind of have this step us through this in very small steps. So I think probably more so than most of them, these notes really will help push you in the direction and kind of train you to think about these questions in a correct way. So first off, we need to make sure that we understand why logarithms are such a big deal in math. What can they do that is unique to other algebra stuff? And that is that they can solve exponential equations. So anytime you have a variable in the exponent, unless it's just one you can do in your head, which is pretty rare, the only way you can solve those using algebra is with logarithms. All right, so again, this is kind of segmented into a lot of different sections to kind of build you up to the ones that I need you to be able to do by the end of this. So we're going to start off as easy as possible. So sometimes you don't really have to know much about logarithms or logarithm properties if it's something that you can do in your head. So 5 to what power gives us 25? It's obviously 2. 5 squared is 25. 2 to the 4th gives us 16. Because 2 multiplied by itself 4 times would give us 16. And I don't know if you'd call this a log property, but if you can read a logarithm, this is asking 2 to what power gives you 8. And 3 to what power gives you 9. So a few of the book questions, and I think maybe even 1 or 2 of the quiz questions, which again is still not next class, it'll be the class after. So we'll have one class to kind of summarize and review 3.3 and 3.4 together next time. But if it's easy enough to do in your head, then of course take the easy way out. Just do it in your head. Okay, but then there's going to be times like question 6 where you're not going to be able to do that. You don't know the exponent of e that's going to give you 5 without doing some logarithmic work. So probably the most common trick that you're going to need to use, not just on questions 6, 7, and 8, but pretty much throughout this whole worksheet and then the whole book assignment, is consider changing it from exponential form to logarithmic form. And that's why we introduced that to you earlier and have you practice it. That's why you really need to be able to switch these forms. So sometimes when you switch the form, Remember to go to logarithmic form, you get to put log out front. You just have to switch the x and the 5. And if it leaves you with x equals, then there's your answer. You know what x is. The reason why you couldn't do that in your head is because that's some weird decimal. Now, this bugs me just a tiny bit, and technically this is correct, but remember log base c just means natural log. So in math, the back of the book and stuff is never going to say log base c. I would not count that wrong on your quiz because technically these are saying the same things, but you should try to make a habit out of doing this. So again, variable stuck up in the exponent. If I try to switch the forms, I know how big x is, so I know the solution to that equation. By the way, this fits one of the properties we talked about last time too. If you notice, like if I wanted to check this and I plugged it in over here, I would be left with 10 to the log base 10 of 3, which we know comes out to be 3 from that log property we had talked about. So knowing that log property, you could actually plug it in and see that it does work. Okay, and then one last time, I could try to put this in logarithmic form. If it solves your equation, then don't try to make it more complicated than that. But switching from exponential form to logarithmic form, definitely one of the most common things you'll need to do in these questions. Even the more complicated questions, this is going to be one of the steps. Now, a less common trick, 9, 10, and 11 are the same 3 questions, but I want to show you a different approach, because sometimes this is needed and sometimes you might think this is easier. But in mathematics, we can do this trick where we can take the log of both sides or the natural log of both sides. It doesn't really matter. I tend to do natural log just because that's what we do in calculus. But you can take the natural log of the left side as long as you're willing to take the natural log of the right side. That's considered to be balanced. And the reason why you might take this approach is with exponent rules. Now x is an exponent on something I'm taking the log of, so x can come down out front. And since the natural log of e is 1, I got that the answer was natural log of 5. Notice, same question as over here, completely different approach, but same answer. Again, I'm showing you this because occasionally you have to do this. Sometimes this is your only choice. And on these questions, obviously, you could do either one. So on 10, if I took the natural log of both sides, keeps my equation balanced. Now, because of exponent properties, I could bring this down out front. And then, I don't know, natural log of 10 is a nasty number here, but it's just a number. Undo times with divide. Now, that looks different than this, but you should actually realize that these are the same thing. If you really understand change of base formula, if I asked you to estimate this in your calculator, although your calculator has base 10, but if I asked you to estimate this in your calculator using change of base, you could do log of 3 over log of 10, or you could do natural log of 3 over natural log of 10, which is just how I ended up writing it this way. So they are equivalent even though they look different. Alright, and then one last time just to try to focus on this, we could take the log or natural log of both sides. As long as you do it to both sides, it's fine. Then because of exponent properties on the left, you can bring the x out of the exponent, and you probably still have some other work to do, but the other work is at least not logarithmic stuff. Just undo times with divide. Same thing. That answer looks a little bit different than question 8, but they are equivalent. And unfortunate for me, when we get to our next quiz and next test, is a lot of times you guys can have the same answers and they can all be correct, but you might write them 4 or 5 different ways. And so for me, I have to do a lot more work when I grade your papers, because if you don't have it written the same way I did, yours could still be fine, and I have to make sure that your way also is equivalent. But from this little section, if it's an exponential form, consider switching it to logarithmic form. That works a lot of the time. If you would prefer to take the log or natural log of both sides, that's fine too. But mostly this is kind of a last case type of thing. If you don't know what else to try, you might try to take the log of both sides. Okay, next little section, we could go the other way. So if switching from exponential to logarithmic sometimes solves equations, sometimes going from logarithmic to exponential is a good idea. So question 10, this is an understood base 10. This is in logarithmic form, and if I switched it to exponential form, I know how big x is supposed to be. And once you know what x equals, it has been solved. Of course, again, you're welcome to plug it in and then simplify this, and you can see that it is actually -1. In fact, that's probably good practice for you. But okay, natural log means log base e, so rewrite it to log base e if you want to. Switch the forms, and then sometimes that's enough to know what x equals. Nothing you're ever going to think of just from guess and check. You're never going to try the number e to the -7. But if you can switch from logarithmic form to exponential form, which you should already be able to do, that's enough. Okay, so just trying to hammer the point home here with 14 and 15. Switch the forms. I guess this one's not quite solved. But we could square root both sides. Logarithmic form, switch to exponential form, and then we know what x equals. So the last two sections, again, probably the ones we're going to use the most, but switch the forms. Okay, so now we're going to slowly step out of that and work towards more difficult questions. Okay, so on these questions, we're still going to switch to forms, but these are a little bit longer questions where we're going to have to do a little bit more work to finish the question. And I actually did this on a couple already. But this logarithmic form is the same as this exponential form. I know this is not my answer because I don't know what x equals, but I just need to finish off the basic algebra here. I need to undo a -1 with the +1, undo a ×2 with the divide by 2. Of course, it makes the question a little bit longer, but that's stuff you guys have been doing for years, so you should feel pretty good. The main step there is still switching the forms. 17 is in exponential form, so if I switched it to logarithmic form, I almost know what x equals. Technically, I know what 3x equals, but I could just divide both sides by 3. And a lot of these answers are not going to be very pretty. You're not going to feel real confident because they're not nice whole number answers, but we'll talk about a way to check your answers before the notes are over. In fact, the book assignment we're going to look at today, most of the questions are even, so you can't just check them in the back of the book. You'll need to check them with the calculator. Okay, so I could switch the forms because that's the most common thing. If I have x equals, circle your answer. If I don't have x equals, just do the rest of the work. Multiply this side by -1, multiply that side by -1. Switch the forms. Undo any basic arithmetic. Undo add, subtract, multiply, or divide. Since that's 100, I'll just go ahead and do 100 minus 7. I can do that in my head. Bless you. Now again, if I'm not going to harp on this a lot, but on the quiz, when you probably won't have a calculator, you don't just have to cross your fingers and hope that this works. I don't expect you to do this on every question, but if I plug this in, this would be 100. 10 to the second power gives me 100. which is what that's supposed to say. So if you're willing to plug it in, you can check it pretty easily. Okay, so at this point we've mostly talked about switching forms, and then undoing add, subtract, multiply, or divide at the end of the question. And in the next section we're going to undo add, subtract, multiply, or divide at the beginning of the question. 20, 21, 22, and 23, none of these are set up in a way where you should be switching the forms yet. Some of they've got stuff in the way. +9's in the way, this 2's in the way, this +5's in the way. So just get rid of that stuff first. Undo a +9 with the -9, and then you can switch the forms to get your answer. Undo the ×2 with the divided by 2. Switch the forms, and you have your answer. Undo a +5 with the -5. Switch the forms. Undo a ×7 with the divide 7. Switch the forms. So we're still switching the forms pretty much every single question, but you can't just switch the form right away. It's got to look a certain way before you can switch the forms. So starting with question 20, I undid add, then I undid times, then I undid an add, and then I undid a times. Obviously we could have undone subtract or multiply also, but get that stuff out of the way the easiest way possible. Just deal with it at the beginning. Alright, and then finally for the rest of the front page here, you could just combine those two ideas. Sometimes you need to undo add, subtract, multiply, and divide at the start of the question, switch forms, and then maybe undo add, subtract, multiply, or divide to finish the question. So question 24, we could both divide both sides by 2. Now that it's in exponential form, I could switch the form. And of course, if I want to go from 3x equals to just x equals, I would like to divide both sides by 3. So undid arithmetic of multiplication before I switched the forms. I did arithmetic of multiplication after I switched the forms. Okay, so again, if you just glance at 25, it definitely looks scarier than the first few questions we did, but just undo what you can. Let's see, this would be 20. Undo multiplication or anything else you can do. At some point, you've got to deal with the exponent and get anything out of there. And the most common way to do that is switch it from exponential to logarithmic. And then if you can do that, you should be home free, because then you just divide both sides by 5. So again, the star in this little section was still switching the forms. I know that you can undo add, subtract, multiply, or divide. I'm just highlighting. Sometimes you need to do it before you switch the form, sometimes you need to do it after, or sometimes you need to do both, just depending on how complex the question is. But even so, I still did this in 2-3 steps, so it's not like it's impossible. Okay, on to the back page. I showed one like this yesterday, but occasionally the only way to start these questions, so this is different now, we can't just switch the forms. We still will be switching the forms, I think, some of these, but we have to start off by expanding and or condensing. So since these are both log base 2 separated by addition, what we talked about on Monday is you can squeeze those together, condense them into a single logarithm with multiplication, 5 times x. And as long as that tool is on your radar and at some point you think to try that step, now it's no different than the front page. I would still undo any basic arithmetic that I could, nothing to be done. I'm still going to probably switch the form, and I'm still going to finish with any basic arithmetic, like undoing a times 5. But occasionally, questions like these, you just can't do anything until you expand or condense. So you have to have that on your radar when it doesn't work out the way that the rest of them look. Okay, the only other way we talked about condensing yesterday is if they were same type of logarithms, both log base 7s, or Monday, I'm sorry, I did it yesterday too, but if they're separated by subtraction, then you can condense into division. And then now it's similar to the front page. Logarithmic form, equivalent exponential form, undo divide 3 by multiplying by 3. Answer is whatever 3 times 7 to the 7th is. In fact, that number is probably too big for your calculator to even handle. 7 to the 7th is pretty big, but not really any harder. Okay, and then we got just one more because this one doesn't fit there. I meant to take that off, but 2 type of logs that are the same, if they're separated by add or subtract, we can condense them with multiplication or division. Just depends on what they're separated by. Then you can switch the forms. Now, here's one of the most common questions, or one of the last things that students check off as far as their understanding. If you don't understand where this e is coming from, you need to make sure that you do one more step here. Natural log just means log base e. If you didn't see where that e came from, you need to force yourself to write in that one extra step so that you can see the e and you can see where it's coming from. I think you've probably seen that enough times in this class where I don't have to write that every single time, but if you struggle to see where the e is, just do this one step. Change natural log to log base e, and then you can see the e. So we're still building upon the front page, but I'm showing you that occasionally your only option to start off is expand or condense. Okay, 30 and 31 are not real interesting, but the type of equations we ask you to solve in section 3.2 are still fair game. So I know you've had a spring break between those, but these were much simpler. If this is log base 2 and this is log base 2, that part's already equal, so you just need to make sure that the insides are also equal. And then solve as normal. Now, it's in your interest to plug it in and make sure that the left and the right side are equal, but it's also necessary to make sure that you don't have any extraneous answers. Your answer can be 0 and your answer can be negative, but you can't plug it in and take the log of 0 or take the log of a negative. Okay, same idea with this one. This one would have been a good fair question for your last test, because this is one of the properties we ask you to know. All that becomes 8. And if you know that, undo the plus 2. So those random 3.2 properties, again, there's only a handful of them, but if you feel rusty on those because of spring break, you might want to look at your 3.2 notes for a couple minutes. Certainly wouldn't hurt. Okay, and so to finish off here, I've got one kind of unique question type, so you need to have an idea of how to start that. I want to look at one real life example of, I know these equations don't look like something from the real life, so we'll look at one like that. And then we'll talk about how to check these with your calculator, since that's what you'll need to do on the book assignment. Of course, you guys are welcome to take turns in your group, so maybe just one. You only have to check one every other couple questions or something. And then I've got a list of kind of a checklist of what we went through today. So when you see questions like this, where you've got 1, 2, 3 terms, None of the other stuff I talked about is going to help you start this question. There's not any basic algebra to be undone. You can't just switch the form. You can't expand or condense. If nothing else works, then you need to consider, just know that it's possible that you might need to factor this. So you're going to have to ask yourself, what times what gives you e to the 2x? E to the x times e to the x gives you e to the 2x. When you multiply things with the same base, you add the exponents. You're going to have to think about two numbers that multiply to 4, like maybe -4 and -1. And you need to check. Make sure that the outer part of FOIL combined with the inner part of FOIL gives you -5 e to the x. If it doesn't, guess something else. If the guess and check is not working out, product sum method will still work. Even though this has e stuff in it, product sum is still perfectly fine. Okay, and then of course, like any factoring you've ever done, you can set each factor equal to 0, and now it's like the front page. Undo subtractions, maybe switch the forms. And then, I mean, technically you've got your answers there. Instead of saying log base e of 4, I would feel much more comfortable saying natural log of 4. And over here, instead of saying natural log of 1, I would feel more comfortable saying 0, because natural log of 1 is 0. But technically it's equivalent. So all I need you to get out of that example is when none of the normal stuff is working, if it looks like that, you have to know to try to factor it. If you don't try to factor that, then it ain't going to work out. Okay, so to kind of at least give you some, as much as I'd love to spend an extra week on these question types and do lots of real world type of problems, we just don't do that because we have other stuff we'd like to get to. But one thing we talked about in section 3.1 was compound interest stuff, like compounding continuously. That was the PERT formula. As far as I know, if you went to go make an investment at a bank or got a loan at a bank, that's just what they would use. I'm pretty sure they use continuously. We talked about the starting amount goes in for P, the principal. E is not a variable, E is a number. We talked about the rate needs to go in as a decimal. But what we did not do to you in section 3.1 when we looked at this is we would have given you the time and you could just throw all this in your calculator and you would know how much your investment was worth. This question's about an investment. But now that we have some experience with logarithms, we can say, I know how much I want the investment to be worth. This hypothetical question's about saving up for a car. So if your car you want $6,000, you know what your goal is, and what you're interested in is how long do I have to wait if I don't contribute any more money? How long am I going to have to wait for that $2,000 to become $6,000? So you would be solving for t, which is a variable in the exponent. So this is an exponential equation, and this is where logarithms will shine. As crazy as this equation looks, I'm going to be able to solve it using the same things that I've been bugging you about all morning, like undoing times with divide, like switching the forms. And actually I'm going to switch these two. Not that it matters, but typically you guys do much better switching the forms if it looks like this instead of looking like this. But these are the same thing. And once again, undo times with divide. The exact amount of time you would have to wait. Now, I don't know that you would care about the exact amount of time you'd have to wait, but that's the exact amount of time, whatever the natural log of 3 over 0.02 is. So the bad news is that's about 55 years. So chances are, if this was your plan to save up for your first car, you know, you're not going to want to wait 55 years. You're going to have to figure out how to contribute some more money. But main thing is you can solve real world any exponential equation using the same old steps we talked about on the front page. Okay, so next up, what I want to talk about is this equation. And actually for all of these, I didn't want to say it 20 times, so I saved it for the end. A lot of these answers have some really unlooking formats. These answers don't look like nice whole numbers that make you feel good about your work. You do this and this looks crazy. Or you're doing the book assignment and it's an even question and there's no other way for you to check your answer anyway. We need to talk about an easy way to check this. And that is with your calculator and the store button. So I've shown you the store button before, but if you type in what you think the answer is, hit the store button down here in the bottom left, puts an arrow on your screen, and then you can store this in for any letter. I usually just do X for convenience, but for this question I'll actually do alpha 4, which gives me T, because that question was about T. That's where I typed in my calculator and told you it would be about 55 years you'd be waiting. But if I want to see if that really makes this stuff be 6,000, I can test. Principal times E. Make sure you're using the correct E here. This capital E is if you're typing a message. The number E is second divide. To the RT, and I can just plug in T here because my calculator knows what T is, and if this is correct, it's supposed to be 6,000. That's what I did on my paper. So not just close to 6,000, it should be exactly 6,000. I mean, that's what we're trying to do when we solve this equation. So by storing that variable in, typing in one side of your equation to see that it equals the other side of the equation, then it doesn't matter how messy or crazy this answer looks. You can still feel confident that you did it correctly. And again, that doesn't take very long, especially once you get the habit of storing. But on the book assignments, you guys might want to divide that up. One person check the first one with the calculator and let everybody know, and the second one somebody else could check, and then that way you're kind of splitting it up, but all getting some practice. Okay, at the end, I kind of just have a little checklist of trying to summarize the things we've talked about, but I'll do the same thing just looking at this. So you need to know why logarithms are important. Sometimes you can just do them in your head, so do that since that's the easiest. Switching from exponential to logarithmic or logarithmic to exponential came up in almost every single question on this. Much rarer, but still sometimes applicable, is taking the log of both sides or natural log of both sides. The harder questions are going to have you do a little bit of undoing add, subtract, multiply, or divide at the end of the question, or at the start of the question, or both. Some questions you won't be able to start unless you expand or condense first. Some questions will look like what we did from 3.2, where you mostly just need to know some properties. And then finally, if you have one that looks like this, where none of the other stuff works, you probably need to try to factor it. So that's kind of the flow chart that you need to try to sketch out in your head as you work through these, so that as you get stuck, you know what else that you should try. Alright, so if you don't have out a blank piece of paper yet, go ahead and get that out, please. And then dive into it and start to see how it goes. Now this is also a longer assignment like 3.3 was, but unlike 3.3, some of these questions won't be as quick, but I can give you the rest of class today, and I can give you some more class time on Friday. So If you don't get the book assignment finished in class, you don't have to worry about it for homework at this point. But of course, the more you get done in class, the less you may end up having homework eventually. So, all right, so as we've been doing, you guys go ahead and copy the assignment down, try the first few for a while, start to figure out which ones you're getting stuck on, and I have a timer going, so I will interrupt you in about 10 to 15 minutes and try to help clear up the first problems you're having. All right. Is there anything you'd like me to go over with you yet? Number what? Number 1? Sure. To solve exponential and logarithmic equations, you can use the one-to-one and inverse properties below. So a to the x is equal to a to the y. That's true if and only if x and y are the same. The bases are the same. If you want the whole thing to be the same, the exponents have to be the same too. There's part A. Let's see, B. If you have log base a over here, log base a over here, an x and a y, the only way these two equations are equal is, again, if x and y are the same thing. Bases are already equal, but you need to make sure you're taking the log of both things before you could say they were equal. Okay, C is one of our properties from 3.2. If you have a number to the log of a base with the same number of something, all of that just comes out to be the something. And for D, this one kind of has two properties to it, but here I would say bring the x down. Since x is an exponent on something we're taking the log of, it can come down out front. And then log base a of a would just be 1, because this is asking you a to what power gives you 1. So your answer comes from x times 1, which would be x. Okay, anything more specific about number 1? It's good. Okay. Okay, others y'all have found and have ready to go? What you got?
17.
Number 17. Okay, so 17's asking us to do two things. It wants us to estimate the solution, or I'm sorry, approximate the point of the intersections. So one graph looks like this, one graph looks like this. Now my graph's not accurate at all, but it looks like, I don't know, I think that is supposed to be 3. X equals 3 is how I would estimate that from a graphical standpoint. But then it says solve the equations algebraically to verify. So they want us to set f of x equal to g of x. This is f of x, this was g of x. And then solve this algebraically. But that's one we can do in our head, because 2 to the third gives us a nice whole number of 8. So they just want you to see that what you're doing algebraically in some of these questions also could be done if you had a calculator graphically. If you graph the left side of the equation and the right side of the equation, where they intersect is where they would be equal. So they're just trying to remind you of that graphical approach too. As far as checking your answers though, I still think it's a lot quicker to store than it is to graph them and find the intersections. But okay, others you've got ready? I don't mind however many y'all have ready to go, but there's no point in waiting if you've got some. Number 20. Okay, so this one looks kind of different, but this goes back to that question number 1A. If you realize that the bases are already equal and you want this entire equation to be equal, you need to make sure that the exponents are also equal. So you need to set this exponent equal to that exponent. Now to solve this, there's a very specific path you have to take, because this is a quadratic and you should not be getting creative here. To solve a quadratic, you should move everything to one side, side equal to 0. Then worst case quadratic formula. That's not much fun, but it always works. Better case scenario is that it factors, and unfortunately this one doesn't factor. So I guess we'll have to do quadratic formula here. So A is 1, B is -1, C is -1. Now, of course, we don't need quadratic formula often. I think it does come up maybe in a couple questions here, but this is by far the most important formula that y'all needed to get out of Algebra 2. So plug in a -1 for B, plug in a -1 for B again, plug in a 1 for A, a -1 for C, and a 1 for A again. And again, I know that sounds like it might be terrible, but it actually should come together pretty quickly. All you could really do was 2 times 1 in the denominator and 1 plus 4 for the discriminant, and it doesn't simplify more than that anyway. So again, quadratic formula is not all of a sudden super important to us, but I do think, if I remember correctly from the last couple of years, I think you do need this on a couple of questions. So you might want to jot that down if you don't remember it. Only need that if you're solving a quadratic that doesn't factor. Or you could just use it on a quadratic if you didn't want to bother with the factoring, I guess. Okay, 1 or 2 more. Okay, then I'll give you a little bit more time to work before I interrupt again. I'll leave this one back up for, I'll leave it up for another 30 seconds or so, and then I'll switch back to the question number on the agenda page. Now, I guess I should also say with this assignment, it's pretty unusual that we give you so many even questions, and we're not doing that because we're worried that you would just look up the answers in the back, because you're not going to magically just come up with these answers without some work shown anyway. But we pick out a lot of the even questions to really force you to try checking some of those answers multiple times with the store button. That's just such a valuable skill that y'all don't practice on a regular basis. So, and again, just to be clear, you don't have to try to be finishing this today. Get as much done as you can. It is not due on Friday. You'll have a little more time. it's time to take a few more questions if you have them. Yeah. Number 30. Again, this kind of came up in the notes, but just to be clear here, if you did question 30 and your answer ends up looking different than mine, yours still might be okay. It just kind of depends on some of the steps that you take, like if you took the natural log of both sides versus taking the log of both sides, stuff like that. So be cautious of that. But looking at question 30, I see that I could at least undo some basic algebra. I could at least divide both sides by 8 first. And then that makes it a little simpler. This is exponential form, so if I switch it to logarithmic form, 5 and 6 minus x would switch places, and then of course it's going to have log in it. And now it looks like I just need 2 basic steps of algebra. I could subtract the 6 over, and then finally divide both sides by -1. So that's probably how most people's answers look. But again, don't just automatically assume your answer is wrong, especially if you feel confident about it, if it looks a little different. You can type in my answer, look at the decimal in the calculator, and then you can type in your answer and look at the decimal in the calculator. And if they're the exact same 8 or 9 decimals, then you can assume that they're equivalent. But again, there's multiple ways you could have done this. Everybody should have started with dividing by 8, but I chose to switch the form, which is what I would think you would probably do too. But again, technically you could have taken the log of both sides or the natural log of both sides, and your answer could still be correct but look different. So, okay, another question or two? Yes,
38.
Sure. All right, 38 is a great one to ask because this one just stands out a little bit. A lot of these questions is kind of death by repetition. You're switching the form almost every single question, so you're just kind of getting in the habit of doing that. But mentally, I'm thinking about how the notes are laid out so I can go through that process. I can't do this in my head. This isn't exponential form or logarithmic form where I could switch them. It's not a factoring type. It's not one I could expand or condense logarithms. There's not even logarithms on here. But one thing that showed up in your notes that I showed you as an option, I also mentioned that occasionally it's your only option. And that is taking the log or natural log of both sides. Again, you have to know that as a tool because sometimes, like question 38, it's your only option. The reason taking the log of both sides is helpful is now x plus 1 is an exponent on something I'm taking the log of, so x plus 1 can come down. Same with x plus 2. So same log property. I don't know. Now it's still a little intimidating looking, but we're really done with all the logarithm stuff. That's the only logarithm step was to know that you could take the log of both sides and why these exponents come down. But I could distribute this natural log of 2. It's just a number. Natural log of e is just 1, so x plus 1 times 1 would say that. If I'm trying to solve for x, I would want to move all the x stuff over to the left and any of the constant stuff to the right. Again, 2 natural log of 2 is just a number. So I'm treating it like a number. It would be nice if I could just combine these, but it's also not a problem if I don't. And then here at the end, I guess this is a little bit different. This did not come up in our notes, but this is a common issue even for calculus students. Do all this, that's great, but at the end of the question, if you can't recognize that this and this have a GCF, and it doesn't really matter if you can take a GCF, you have to practice seeing the GCF. They both had an X, so I could pull it out and then finish with division. Undo times with divide. So that weird looking answer would be one possible answer. But again, I took the natural log of both sides at the start. You could have just as well taken the log of both sides, log base 10 of both sides. And so your answer would have, these would be logs instead, and there would be a little bit extra here, because since I picked natural log, this just went to 1, which is why we often do that in calculus, because since there's so many e's in these questions, it's nice if some of it goes away, whereas if you use a regular log, it wouldn't go away. But that's a good one to put a star by. Usually we put maybe one of those on your test, so you need to know that that's an option when nothing else works. Okay, 1 or 2 more. Okay, I think we've got time for maybe one more timer, and then time for me to take one more set of questions. So I'll reset the timer here. Again, we got about 25 class minutes, so I'll probably wait about 15, and that'll give me 10 minutes to finish up your questions. Reminder, on Friday I will have like a practice quiz for you that mixes 3-3 and 3-4 stuff together. So we will do that and use it as a practice quiz to help identify maybe what you need to study more. And then I'll be able to give you more class time to work on this book assignment. So unless you just feel like you're behind everybody else, you don't need to worry about it for homework yet. to about 10 minutes here before you're dismissed, so this is really your last good chance today, although you'll have more chances on Friday. But anything else that I can help you with before we run out of time today? 70? Is this your last one? Okay, so part of what's different about this one is you physically can't solve this by hand. That's why the directions are saying use a graphing utility to graph and then approximate the 3 decimal places. So if you remember what we did back on question 17, it's basically the same idea, except 17 they graphed for us, whereas question 70 we need to graph. So graph one side as the left side of the equation, make another equation the right side of the equation, graph those, and when they're in the same place at the same time, this would be the answer. Now again, some stuff we just physically can't solve by hand, so calculator approximation is the best we can do. And then to get your calculator to find that spot, you should not be using trace and just putting it close. That's not good enough. Like, it's pretty close, but you need to ask your calculator to find that exact intersection. So if you do second trace, we use 0 quite a bit. Hopefully in Algebra 2 you did min and max a bunch, because we do that a lot in calculus, but we want it to find the intersect. So it's going to ask you for first curve to hit enter, so just make sure your cursor's on one of them. This is if you had like a bunch of graphs on here at once. Then the cursor will move. It's asking to make sure that's the second curve you want, so make sure that's correct before you hit enter. Hit enter to skip guess, and then the calculator will bounce that back and forth until it figures out where they're at the same place at the same time. So that would be about 2.264. About 2.264. And actually I guess I didn't read the directions very carefully. It did say verify algebraically. So I had glanced at this just a touch too quickly. There was actually something I could have done to do this by hand. I could have added this over, and the reason adding it over helps is now these two can be condensed into a single logarithm by multiplication. Then you could switch the forms, and then it's a quadratic. Unfortunately, that's not going to factor, but if I do negative b plus or minus square root b squared minus 4ac all over 2 times a, I appeared to get 2 answers. Quadratic formula gives you 2 answers. Now the graph only showed me 1 answer, and that's because one of these two is extraneous. The negative 1 minus this stuff would be a negative number, divided by 2 is negative, and I can't plug a negative number in here. We can't take the log of 0 or the log of negative. And unless I'm just going too quickly, negative 1 plus the square root of 1 plus 4 e squared all over 2 is same decimal that the graph gave me. So kind of just depends on what you're trying to use it for. If you just need to know 8 or 9 decimals accurate, calculator is perfectly fine. But if you're building something important, you really should not be rounding and rounding and rounding, because your stuff just gets further and further off. Talking about big projects as an engineer or something, that would make a big difference. So. All right, so we've got about 5 minutes here till we're dismissed. So again, I don't expect you to finish this up for homework unless, well, you still don't have to finish it up. But if you feel like you fell behind a little bit, then please do a little bit extra. And I can give you some more time on Friday to finish up. But I guess I will go ahead, if you give me just a second, I will open it up in Google Classroom for those of you that I didn't think many people would finish it today, but I do encourage you to go ahead and turn it in if you do have it finished. Of course, make sure you attach your work to these questions. These would definitely not give you any points if you don't have your work with them. Okay. And that's opened up now if you want to do it today. But start to finish your final question, your final thought for today. If you brought a calculator, please bring it back